All right, so multiplication of matrices, which is quite complicated and can get tricky very quickly. So we'll just look at 2 by 2 matrices. We won't go into 3 by 3s for multiplication by hand because really it does nothing to your understanding and just complicates issues if you forget things. But I do want you to make sure you understand how multiplication of 2 by 2s works so that theoretically, if I threw you a 3 by 3, you could do it, but I'm not going to do that. All right, so just don't let it hang over your head. All right, so the first thing to look at is that we've got these two matrices. A equals this one here, which is a 2 by 2. B equals this one here, which is also a 2 by 2. All right, so I'm going to show you how it works, and then we'll discuss some implications of it. So first of all, A times B equals A times B, written like that. All right, so the next thing is that multiplication of matrices works by doing rows multiplied by columns. All right, so rows by columns. Remember that. That is the most important thing and probably the catch cry that I will say constantly just to annoy you. All right, so rows. So first one, 1 by 5 plus 3 by 6. Now that is all the number, or the answer to that is going to be the number in the top left position of the answer matrix. All right, so notice that it's the two black numbers multiplied together plus a red number, the 3, and the number directly below it, which is the 6. Okay, so it's rows by columns. Now, that's the top left. The top right position is going to be the same row because it's top, but by the right column. So it's going to be 1 times the red one plus the red 3 times the green 3, the number below it. Okay, so remember it's the top row, 1 and 3, 1 and 3, by the right column, which is 1 and 3. And those numbers added and multiplied are going to be the answer in the top right position. Okay, now the bottom left position is given by the bottom row multiplied by the the left column. So it's going to be 4 times 5 plus 2 times 6. So you're starting to see some patterns emerge here. You're starting to see that this left position has got both 5 and 6 in it because it's the left column. 5 and 6 are in both. And all that changes is the row here and here. All right. So then the bottom right position is going to be given by 4 again times the right column, which is starting with a 1, plus 2 times 3. Okay, and again to draw that parallel, you notice that in the top right position there's a 1 and a 3, and over here there's a 1 and a 3 as well. And all that's changed is the 4 and the 2 as they came from the bottom row instead of being in the top row. All right, so now the next step is to simplify all of these things. So your first one is, so it's going to be 1 by 5 is 5, 3 by 6 is 18, 5 and 18 make 23. I'm putting the brackets there just to keep it very clear in our mind that these are distinct elements in the matrix. Top right, 1 by 1 is 1, 3 by 3 is 9, so that's 10. 4 by 5 is 20, 2 by 6 is 12, so that's 32. And 4 by 1 is 4, and 2 by 3 is 6, so that's 10 also. All right, and don't forget to wrap it off with your matrix. Now, if you didn't want to put in your brackets, you can just erase them out. They're not needed. I just put them in there to remind us that they are distinct elements in the matrix. Okay, so that's how you do multiplication. It is rows by columns and added in the middle. Okay, there are going to be numerous calculations for each position. All right, now something that you've been told quite often in maths up to this point is that multiplication is commutative, which means that 2 times 3 is the same as 3 times 2. And in matrices, this is not true, okay? And I'll show you. I'll use the same two examples, but in this case, I'm going to do B times A instead of A times B. All right, so I'll lay them out there. First of all, I have 5, 1, 6, 3. That's matrix B times matrix A, which is 1, 3, 4, 2. All right. Now I'm going to lay out my answer matrix. I'm going to make it quite large. And I'm going to go, so first row by first column. So 5 times 1 plus 1 times 4. So that's 5 times 1, 1 times 4. Then I'm going to go first row, second column, which is 5 times 3 plus 1 times 2. Then I'm going to go second row, first column, so that's 6 times 4 plus 3 times 4. Oops, sorry, 6 times 1. 6 times 1 plus 3 times 4. Then I'm going to go second row, second column, so that's 6 by 3 plus 3 by 2. So you can see how easy it is to lose track of the elements and where they multiply and which one they belong with. And that's why every time I went row, column, just to keep it clear in my mind which one was belonging to which calculation. So now let's simplify them. 5 by 1 is 5, 1 by 4 is 4, so this is 9. 5 by 3 is 15, plus 1 by 2 is 2, so that's 17. 6 by 1 is, that should be a plus there, 6 by 1 is 6, and 3 by 4 is 12, so that's 18, and 6 by 3 is 18, plus 3 by 2 is 6, which is 24. All right, so compare. This is AB, and this is BA. Notice they are not the same. All right, and this is happening because the addition or the multiplication and addition happens at different points in each of the two problems. All right, it is not commutative like other multiplication we've been working with. Okay, so it's summarized in a rule like this. AB does not equal BA. All right, to finish off, we're going to look at one last condition which has to be met for multiplication to work. I'm going to look at this example here where A equals this matrix and B equals this matrix. And I'm going to try and multiply A times B. All right, so it's going to be, set it out like, oh, I don't need that line there. Don't be tempted to put that line in. It's like a fraction line, but not needed. All right, so this is what the multiplication would look like. Now, normally, with multiplication, I would go rows times columns. So I'll try it out. So I've got the first row, which is 5 by 2, plus, and then I run into a problem. I don't have anything to multiply the 3 by. There's nothing else in the first row that can multiply to the 3. So I seem to have hit a snag. Can I do this anything with the first row, second column? And again, I would run into a problem. 5 by 4 plus something by 6. I don't have anything to do that with. So this is the last criteria. To do multiplication, all right, we need to work out the sizes of each of these matrices. So this is a 2 rows by 1 column, and this is a 2 rows by 2 columns. All right, and then we're going to look at them in the order that we want to multiply them. So this was A times B, and this was a 2 by 1 and a 2 by 2. And I'm going to compare the columns in the first with the rows in the second. And if they don't match, then there is no multiplication possible. So shortcut is to circle those two inside numbers. If they are not the same, I cannot multiply, like we've just seen in this example here. But looking back at the previous example, we might remember that B times A is different to A times B. So I'll try it out. So 2 by 2, that's the first one, and a 2 by 1. And you might notice that now the two inside numbers, the columns in B and the rows in A, are the same, which means that I should be able to flip them over and multiply them. So if I write B first, 3, 6 times 5, 3, we will find out that rows by columns will now work. So this should be 2 by 5 plus 4 by 3 and 3 by 6 plus, sorry, not 3 by 6, 3 by 5, 3 by 5 plus 6 by 3. So you can see here that the order did make a big difference, because in the first instance, rows and columns, or sorry, columns and rows didn't match, and it wasn't possible. In the second instance, columns and rows did match, and it is possible. So you need to be very careful when multiplying matrices together, because it is quite easy to lose track of rows, columns, multiplying elements in different positions, and so on and so forth. All right. To make it as simple as possible, my advice is to copy out the matrices, write the sizes underneath them, and then do something similar to what I've done here. Write down the multiplication you are expected to do, put the sizes that you know, and circle the inside numbers. This will let you know whether or not the multiplication is possible. And if it's not possible, just like with the addition and subtraction, you just say not possible. If it is possible, like in the second instance, you go ahead and do it.